All right, let's take a look here. Of course, I never said this was going to be painless. It never is. Proof writing is kind of difficult. I mean, you haven't seen a lot since geometry when you had to prove like side angle, side stuff. I don't know if you remember that stuff. Okay, so one thing you can't forget is that this is a sum of sequence elements. So whenever you go from k to k plus 1, you're really just adding one more term on. And if you do that, you have to add that same term to the other side. That's the idea. So base case, n is 1. What would that imply? If n is 1, I go up to 3. And that is equal to 4 times 1 squared minus 1, check. Cool. And if you check it for the next one, it would be 3 plus 11. And is that equal to 4 times 2 squared minus 2? Is that true? Yeah, 14 equals 14. True. Cool. All right. So look, at least the first couple work. So it looks like it's at least something to get into, right? The second one didn't work. Screw it. So then I've got assume SK is true, which is 3 plus 11 plus 19 plus 8n minus 5. Oops. So that's the case statement. Now I'm about to write what it is I need to get to know that I'm done. That's why I call it we want to show. We want to show this. If we can show what I'm about to write down, I can stop because I'm done. Right? So I'm establishing what it is that means I'm done. We want to show that assuming this is true, then SK plus 1 is true. And of course, what would SK plus 1 be? 3 plus 11 plus 19 plus 8k minus 5 plus the next term would be ak plus 3. Is that cool? Plug a k plus 1 in. If you plug a k plus 1 in, it'll be 8 times k plus 1 minus 5. What's 8k plus 1 is 8k plus 8. Minus 5 is 8k plus 3. You guys see that? All you're doing is plugging in. For example, if I want to know what the fifth one is, what would I plug in? What would I plug in if I want to know what the fifth one is? I'd plug 5 in. If I want to know what the next one is, I would plug a 6 in, right? So I want to know what the kth one is. Now I want to know what the k plus 1th one is. What do I do then? I plug in k plus 1. That's all there is to it. So when I plug a k plus 1 in, I go out one more term that I just did. So that's still there. That's kind of good to realize. That's still there. I'm adding the next term up, which would be 8k plus 3. Okay. And what would this side have to look like? Like that. Good. Be careful. And you can simplify that a little bit if you want to. Normally you just kind of leave that, because that is the form of the idea. So I kind of leave that alone. I want to mess with the next step to make it show that it's the same as that. So here's the next step. What up here do I know is true? What up here do I not know is true yet? Yeah, this guy. I don't know if that's true yet. So I can start here. I can do anything I want to. I can subtract 1847.3 from both sides, because it's a true equality. I'm not going to do that. Doesn't make any damn sense. What I'm going to do is, if I'm trying to prove this, I'm going to take this that I know is true and make this side at least look like it's supposed to, right? And how do I make this side look like it's supposed to? Add this to it. And the only thing I'm allowed legally to do after that, and actually I'm required to do it, is add the same thing to the other side, right? Property of equality. If you add something to one side, you got to add it to the other side. And then the whole purpose is, if I can make this side become this, I've proven it. I'm done. Because then I've shown what I said I needed to show. And that's what I just told myself. That's when I know to stop. Knowing when to stop is a good thing. So what do I get if I do that? I get, so I got my 3 plus 11. Here's SK. 3 plus 11 plus 19 plus 8K minus 5. And then I add into it 8K plus 3. So it's 4K squared minus K. And I add into it 8K plus 3. Now here's where it's really nice to know the form that I want it to end up in. It gives me a goal and it tells me what the hell to do. I know I want this thing to look like this. So what am I going to try to do? What do I want to kind of take off by itself? The negative K and a minus 1. You guys see that? Let me write this up here so we can see it better. Let me turn this so everybody can see it better. All right. So that's what I added to SK. Because now this side looks like SK plus 1. Right, that's an AK minus 5 triangle. And now I want to make sure that this side looks like SK plus 1 is supposed to look, which is like that. Now look at the end. What's at the end of this? We do this little bit of simplification. There's a minus K minus 1, right? This is what's so cool about this. I know I want to have a minus K minus 1 at the end. So just move a minus K minus 1 at the end. So what's up here then? That minus K is there. I put a minus 1 here, so what's here now? No, I didn't put a plus 1 here. I put a minus 1 here. No. A 4, right? Because if I put a 4 here, isn't that still 3? Okay, good. So I get 4K squared plus 8K plus 4. And all I did was I took a minus K and a minus 1 over there. Now what must this do? Yeah, it's got a factor to be that. And sure enough, the 4 comes out. And what's this factor to be? There. I know I'm done now. I've shown that if the kth one is true, if you start at the kth one, you can get to the k plus 1th one, which means the first one leads to the second one leads to the third leads to the fourth leads to the 18 millionth. It's true forever. Crazy. I think I got maybe about 40 to 50% of you guys on board. But again, you've just learned this today. My God, give yourself a break. Definitely look this over. We'll do number 4. And number 3 is weird because it's got an inequality. So I definitely want to do that next time. Okay.